All right, we have a tank containing 50 liters of oil at time t equals 4. The oil is pumped in at a rate of R, where R is measured in liters per hour, and T is measured in hours. Selected values of R are given in the table above. We're going to use a Wright-Riemann sum to estimate, with 3 subintervals, right, to estimate how much oil is in the tank at 15 hours. Okay, so the Wright-Riemann sum is going to use these 3 subintervals, right? But notice that that this integral, right? So this integral from not 0, sorry, from 4 to 15 of r of t dt, that's going to get, so what the thing that I'm going to use rram for, right? I'm going to use rram to approximate. That's going to give me the amount of oil gained in the tank. So the amount of oil added in that time period. It's not going to give me the total amount at the end. It's going to give me how much is added. What's important here is I also have to recognize that I started with 50 liters of oil. So I'm going to need 50 plus this, because this is how much was in the tank at t as 4, right? So I need both of those values. So the big trick here is that one of the smart wrong answers is going to be if you forget the 50, right? So it's going to mean you did all the math right, but you forgot the 50. So let's go ahead and walk through this. To do my Wright-Riemann sum, right, the width of the rectangle, so my rram, is going to be the width of this rectangle, which would be from 4 to 7, so it's a width of 3, right, times the right height value, because it's rram, so I use the right y value as my height, right? That's the first one. Plus the width of this one, well, that width is going to be 5 because of the 12 minus 7, right? Times the right y value, because again, it's rram, so the only difference between the different approximations methods is they tell you which of the y values to use. And then this one has a width of 3, right, from 12 to 15, and a height of the 5.6. So that's going to be my approximation. Now, so this one's definitely an 18.6, so that's easy enough, right? For the green one, if this were 5 times 6, it would be a 30, so I must be shy by 0.5, so this is a 29.5. And then for the blue one, I get a 15 and a 1.8, so I think I get a 16.8, right? And again, don't be ashamed at any point to do long addition or long multiplication, because you don't want the reason that you get a non-calculator problem like this wrong to be that you added or multiplied wrong. So the 6 and the 5 gives me an 11, so this 8 gives me a 19, I carry the 1, right? These guys are a 10 and a 14, so that's a 24, and then this is a 6. So I get the 64.9, so that's how much is gained in those hours, right? But I had a value of 50 at the start, right? So the total at t equals 15 is going to be 114.9, I believe it was liters, okay? Which is, I think, answer C, okay? Just, again, be cautious, because this is a trap, right? This is a trap answer. This is the answer you get if you do all the math right, but then you forget that there were 50 liters in the tank originally.